Hello there, everyone. I see a few people are still connecting to audio, so we'll wait for them to finish connecting.
recorded 的，你干啥都是 recorded 啊。手真的太小了，你俩就在那看吧。
All right. So today's class is going to focus. In our past classes, we talked mostly about like the meat of the program. So we talked about how to create code that is able to essentially operate different operations, do different things in order to change an input to a correct output. But basically every program in Java especially is going to essentially consist of these various coding operations. Things like for loops, while loops, and if loops, if functions. Remember last time we talked about Connect 4 and how in Connect 4 we used the input to get player input, user input, use the various functions learned, specifically at for loops and while loops, allowing us to repeat various functions, and if loop in order to do different things based on the user input. And then after that, we managed to return the output, which is the board state and whether or not a person won or not. So essentially, we talked all about the meat of the programs, the thing that actually makes the program run. Today, we're going to review that a bit. And for anyone that wasn't here or just missed it, and then we're going to go on to talk more about how to make your program essentially pretty, the extra stuff that makes it look more official. Specifically, things like graphics, how to draw on a program, how to create colors, and how to put images on it. Yeah. So firstly, in order to review, every program is made up of three important things. The program has input. A program is input, and while some various functions may not require user input, all programs need something to tell them what to do in order so that they know what to do. And then you have the operations, which is how the program transforms these inputs into something that the user actually wants. And then it goes to output, which is where it's actually given to the user. So in this case, our input comes from the user by scanning their text in from a terminal, and essentially every time they type in a number, we can grab it in. The computer can take in that number, store it, and then now it is able to use that stored number to do various things. In this case, the specific stored number is going to be the number of rounds, which tells the program how many times to repeat, which is what for and while loops are for. And then the next input that the player does is the column they pick whenever it's their turn. And so using these two pieces of input, we can then transform these inputs into an output that we actually want. And these operations are specifically contained in these functions like check column, which is essentially a mini program we create in order to simplify the program as a whole. Check column uses for loops so that way we can repeat something, because computers in particular are often very basic. While they rely on using multiple basic functions to accomplish a bigger task. Often you'll have to subdivide your main tasks into lots of small tasks that like a child can handle in order for the computer to understand it. Since you can't talk to a computer, you have to use very specific words essentially. So you really have to be very specific with a computer. And so this allows us to essentially separate it in order to make it more clear to both the computer and the programmer. So here we use a for loop to check every individual position and see if it's empty or not. And then we find the empty position, allowing us to know where to put in the necessary token for the Connect 4 board. And finally, we're able to use the for loop again to output the board by outputting each individual square. And then after that, we can then again use various if functions and other stuff like that in order to get our final outputs, which is the win condition, which is the main purpose of this program, and is what the input and operations are all trying to output themselves. if anyone needs like a refresh on what we did, because I think there are some newer faces here, you can go ahead and ask. But if you don't, I'm going to assume that you got all that. Does anyone need any review? Like a bit more in-depth explanation as to how it works? All right, cool. Okay. So yeah, so essentially the past 6 classes, we've all been talking about the main part of a program, input, operation, and output. Now we're going to do a little bit of essentially making it pretty, how to make the program essentially not just simply do an input output, but how to essentially make its output more fancy. Or essentially adding like the extra credit stuff onto it. So in order to add graphics to a Java program, the main way we usually accomplish this is by creating a panel. Essentially, this panel, what it's going to do is it's going to create a window, and then this window is going to be where we draw on it, rather than simply, because if you remember in our Connect 4 program, the way we use our output is simply by writing it out in the form of essentially a text art, where we use like slashes and the letters, like we use the keys on the keyboard in order to create the board with the vertical slashes and the various possible numbers. But by using a panel, we can create a window and then actually draw out this board or whatever it is you want to actually show. So in order to actually create a panel, first off, we have to tell Java that this is not a normal program. This program is specifically meant to create a colored window. So we can do that by telling the Java that this specific piece of code is going to be a Java panel, or essentially it's going to create a window. Make sure you have to import this class, because otherwise Java doesn't know what a JPanel is. You need to import the basic class. The reason it's not automatically imported is because Java likes to say memory. So you will have to remember to put in an import there. Yeah. So now that we have a panel, we now want to actually make a display stuff. Okay, so this is what this is supposed to do is this when you create the panel in the main code, the part that actually runs, it's going to call this a constructor, which it constructs this specific class. It's going to construct this object. And so it's going to essentially call this and then run whatever code's inside to actually create the Java panel. Okay. I could type it all. I'm lazy. I don't feel like typing. Where's it? Yeah, okay, it's this one. All right. So when you first create the panel, obviously Java doesn't know like the specifics. So you have to first initially establish that when you create the panel. And then tell Java that's supposed to be visible. You have to tell what size it is. Let's just say 800 pixels by 800. And then you have to, this is technically optional, but this is basically if you want to make it extremely fancy. That stuff you'll have to probably look at yourself. Yeah. But the most basic thing is you have to tell Java that you can see it, and then you have to set its size. After that, then you can actually start doing things with the panel. So now we've created essentially an empty panel here. So once we run it, it's just going to be a blank white window, and that's not very interesting. In order to actually color it, in order to actually put stuff onto it, we have to use a paint method. Okay. So this paint method is auto incorporated inside JPanel, and this is simply the way it automatically colors itself. It uses a generic graphics input and uses that in order to actually color the window itself. And in order to color things, it's pretty simple. You simply call the graphics. In this case, it's named G, so you just simply call it by its name. And then, hello.
You move out of this way.
What is it really talking about?
Yeah, what is it really talking about?
Sorry, I can't hear you. What'd you say? Did you say something? Lucas and Chris, did you have a question or no? Never mind. I think they may have been. All right. Yeah. So by using the paint and the graphics G methods with it, we can, as you can see here, do various things like draw lines, polygons, or fill polygons or fills. So the main methods you have to learn essentially draw some shape and then fill some shape. And draw simply just creates the perimeter of any shape, while fill creates both the perimeter and fills it in with some color. So if I were to, let's make this, if I were to draw a rectangle and give it the various coordinates, say it starts at x equals 5, y equals 5, has a width of 10, height of 10. This would draw a rectangle with these specific dimensions. And if I used fill rect, and this would also create a rectangle, but it would first create a different place. And because this is fill, this fills the inside of the rectangle. So it's one solid color rather than just a simply outside. And you can experiment with the rest of the various methods here. Like there's a draw line and draw ovals, etc. You can also draw strings. You give it a string and then the X and Y coordinates. The main other thing we're going to talk about is how to change its color, which you simply can call by grabbing its color method. This one needs an input, which is going to be what color you want to set it as. Otherwise, it doesn't know. So in order to do that, we can simply use its basic color. We can use basic color, like its auto-implemented color sets. You can create your own colors as well, but for right now, the basics are fine. If you want to space it in order to put a color as input, you simply call the color class, and then you just type whatever color you want. If you wanted to create a new color, it's very similar to how you would create a scanner. Everything here, like I talked about in the very first class, Java is very much object oriented, and so essentially, it's all about creating objects. And color here is an object, so you can create a color object, call it like col, and it's equal to new color, and then give it, and specifically in this way, you're supposed to give it an R red, green, blue value, the RGB value. It's like 25, 25, 25. Okay, so let me summarize this real quick. So essentially, if you want to add actual like graphics to a program, the main way we do this is by using a Java panel, at least in Java. If you want, you can also experiment with other programs languages like Unity Engine or other things. But since we're talking about Java, we're focusing on how Java handles graphics and images. So you would create a class, a new object, give it some name so that the program knows when you want to use it. And then it has to extend a JPanel, which identifies this class as a window object. Then you create a constructor, which is simply tells the program what happens when you first create it. So when you first create it, the program will set it to true. That will set visible to true so you can see it, and set the size to 800, 800. Then every time the program is painted, and this specifically happens as soon as the window is created, or you can call it by calling it yourself with a, say, you can create a new graphics object and you can paint it yourself, but usually it's auto-painted whenever you resize the window or when the window is first created. So this is mostly automatic. You don't have to really pay too much attention with it. If you ever want to tell the program to repaint it, then you can simply call it by calling the repaint method, which essentially just calls paint by itself. And in order to actually do stuff with this window, you have to first tell the way Java handles it is by drawing various things onto it one at a time, such as lines, rectangles, or ovals. And so each of these, and these are all methods, which, like I said, like I said previously, are mini programs. So they take in an input, then they use this input to conduct operations, which is in this case drawing a various shape based on input, and then returns this output in the form of some color on top of the blank window. So you have to, whenever you call the drawRect method, you have to give it the necessary inputs, and each one has fairly similar inputs, but some not all of them are exactly the same. So you'll have to watch out. Like ovals, for example, when they you also give it a x, y, and a height and width, but the drawing of the oval actually starts at like the very outside edge rather than like say in the center. And finally, you need to set colors so that Java knows, the program knows whenever you're drawing a rectangle what it's supposed to be, what colors it's supposed to be. So essentially, by doing this, we can right now we can put colors and shapes on that program, but that's obviously not good enough. What we really want to know is how to make this change in stuff in relation to whatever our main program is doing. Essentially, what we're focusing right now is how to create this board, which normally just created with normal text, and create an actual Connect 4 board that like looks pretty and everything. For starters, we can essentially take most of this and essentially copy it over. Since after all, we can use the same general idea, color out each individual element by itself. Instead of trying to color the whole board at once, we can just color each element and put in its the right place. And that is how we're going to do it. So firstly, in order to actually, in this specific scenario, if you want to paint something, you want to paint the board. So first off, this program needs to be able to access the board in some way. And in this manner, the best manner of doing it was simply to, when you create this class, this object, you can simply bring in a board as input. And then after you can then set this board to whatever board you gather as input. And so this is probably the easiest way of bringing necessary information. You simply pass it in as an input. You could also, if you didn't want to put in the constructor, you could also create a method called set board, for example. And that would and then you can tell it to take in an input board, and its operation would be to set this board in this specific container to whatever board that you got from the input. You could also do it this way, which would allow you to bypass the constructor. Any methods they find. Essentially, if you want, but essentially the main idea is if you want to draw something, you normally need information from, you need to know what you're drawing. And since a lot of times it's going to be separated into various classes, you'll have to bring it in as input and somehow and then store it inside this individual program in order to actually use it. Yeah. So now let's look at actually how to draw the board. So these first few parts are now originally the way we did it was every time we drew this out, we simply took each element and then simply printed it out. And then whenever we had to go on to the next line, we simply did that as well. The reason, however, this doesn't really, we can't simply copy that. We can't simply just say g.draw oval. You can't just simply tell it to draw oval here, because first of all, these right now, these numbers are unchanging. They're not changing every time we repeat. So every time we repeat this program, it's going to draw an oval in the exact same spot, but we want it to be in different spots. So in other words, every time this repeats, we need this to change. And the easiest way to do that, and the most common way to do that, is simply use the only thing that's changing here, which is these variables, column and row. Every time we go through this for loop iteration, column increases by 1, and every time this first for loop finishes a loop, then row will increase by 1. So every time one of these increases, we can use that to change the position. So in this case, this would help draw each oval in a new position. However, you have to remember that this may not be the position you want. Specifically in this case, row only goes from 0 to however long the board is, and column will only go from 0 to wherever the board is. But since the computer sees everything in pixels, going from the position 0 pixel to position of 1 pixel is not a very big difference, especially since right now our code thinks each oval has a size of 10 by 10. So obviously, the main problem here is that it's not separating each oval by enough. And we can fix this by simply multiplying both of these by some number. So that way, every time we look at the next element in the computer's stored board, when we actually draw it out, it moves 20 pixels to the left or 20 pixels down, which will allow us to actually put down. And we can put this over. So now every time, now we can go through the entire board, and now we're drawing out an oval onto the actual window. But now we have to separate each of these ovals from each other. And so the only normally in the real life version 2.4, the difference would be in color. So we can simply do that. This one is red. This one is blue, and this one does not have a color. It's just empty. And so if you remember, this one is supposed to represent an empty space, and these are filled spaces. So in other words, this has to change from fill oval to draw oval. So now our output looks correct. Every time, we want to draw out the board onto an actual window. And to do that, we need to know each individual element in a list. Specifically, we need to know each individual element in the board. So we can use a double for loop to go through each element in the board without repeating and without doing like extra steps and without missing anything, because each of these will systematically increase from 0 to their necessary number, and they won't skip anything because the only thing changing them is a simple +1 here. So they're going to go through each element in this 2D array, and every time they go through one element, we store it as the value, as an int value, and then we draw it out here. We know this has to be in the right position because because this row and column, they're not jumping around randomly. It's very systematic. They're going one by one. So as long as we follow that pattern, we simply know exactly where to draw them. And then we set this to fill oval because it's supposed to represent a filled spot. So like a filled piece. And this is draw because it's just an empty space. It's just going to represent an open area. Now, okay, so now this section program theoretically is going to draw it now. However, it's not. However, if we run the main program, it's not going to run, and that's because we have not yet put this inside of the main program. Right now, it's still unrelated to our main Connect 4 program, and so in order to actually use the paint and the window that we created, we have to create an object here. So what we're doing here is we're telling the program that you're going to create a new window. You're going to create a variable called cPanel, and it's going to store a Connect 4 panel, or in other words, a window panel. It's going to store a screen inside of here. And we've given this piece of code that creates a screen, we've given it an input called board, which specifically stores whatever the board is. And that way this piece of code here will know that whenever it draws, it knows what it's supposed to draw with. The second thing we need to do is every time we update, first off, we can get rid of this because we're not using the text area to draw anymore. And we're already drawing it. We're drawing it inside a window. Now we need to make sure the window knows when to draw, and we have to make sure to update the board. Because right now, while the board's changing in here, we have specifically right here, the board is changing. And so every time this board changes, then when we draw out the board, the computer knows to draw out the new board because the board has been changed. However, here we've only given it once, and it's never changed again in this area. So every time we make a change here, it won't appear in our window. to counteract this, we have to change the board. And there are two ways to do this. One way is by calling the set board method that I created earlier and simply putting in our new board inside. And another way to do it is by simply doing this exact same code, except instead of telling the program we're doing this codes board, we want to do cPanels board. Essentially, we're telling the program, go to the cPanel object, access the window it's holding. And then inside this window, there's a storage element named board. So I go ahead and access the board and then change that element, change one of the board's elements to the player. This works because we set it to public. So first of all, that means anyone can use it. And secondly, it also works because that's how we're storing the board. Now the board is stored inside this class and it's supposed to be public and accessible to anyone. However, that being said, it's a much better practice to simply create a method like this and select this instead of using the Java default method to set it, because this gives you a little bit more control and is just a lot more safe than editing it directly. So now that we've set the board, we then obviously need to update the window so we can tell it to repaint itself here. So let's see if it worked. Hey, I'm done. So right now it's not creating, it creates the panel, but you don't, right now, as you can clearly see, it's not here. And that's because it's not actually connected to the panel itself. The way panel works is that it creates a window, but that window needs to be placed inside of a frame. And it's weird. Let me get my password back there. This is the final part of any window. And essentially, every time you want to create something, there needs to be a JFrame, a Java frame, and a Java panel. Java panel is what actually does the coloring stuff, but this Java panel needs to be located inside of a Java frame. And so the constructor looks fairly similar. Yeah. So essentially what's going on here is the panel by itself is not actually supposed to be visible. It needs to be located inside something, and which in Java, it's supposed to be located inside of a frame. Essentially, you can create windows, panels that go inside frames that actually can be created by the main program. Where's the notes? So now that we have this frame, now the main problem with this is that you still have to update the board inside panel somehow. And so the easiest way to do this would simply to be create a method that simply create it's the copy of the set board method we did earlier. And we do have to bring this cPanel out. This is not going to load. This subboard. All right. Yeah, so now we've created a frame. This frame will create a panel, and then this panel will should create a window that draws out the necessary things for the board. And then we have the way to change the board here. And so that way it should update itself as well. And it's also going to repaint itself. All right, so as you can see here, we've drawn out very, very small circles. So the main thing here is that obviously this is what we have while the graphics are showing, it's going to take a lot of editing to make them actually be relevant to the actual Connect 4. So in this case, the way we adjust it is by making the size between each of the circle places bigger, make the circles themselves bigger, and then you can also add, say, a yellow or like a red background behind to represent the board itself, because right now it's a bit boring. But now we can see that it's actually formed, and if we type a column here, it colors it. We do so, and every time we do this, so see, right? I think the main thing our code is missing right now is that first of all, the way it flipped around the actual board, it should be rotated a bit. So in other words, it should be facing a different direction. And secondly, you can see that's color should be red as well, meaning that we did not reset the color after each one.
I think your share it only shows the.
Right, it creates a separate window that doesn't go in the.
Yeah, I can't see it.
Oh, so this is what it looks like right now. And so the only paint code we have is the oval drawing, which draws each element in each row and along with the necessary colors.
Okay. I'm pretty sure you can get it by just sharing your whole screen.
I could try that. There it is. All right, cool. Yeah.
We can see it now.
Okay, so let's go ahead and fix it. So obviously the various rows, the various ovals need way more space and be way bigger, so it's actually visible and usable. So we can make them, let's say, and that might be a bit. Make them all 60 by 60. We need to reset the color here. And then the space is gonna be much bigger since now that the ovals are bigger, they're gonna start overlapping. So we need to add much more space between each of these columns and rows. So let's see how it looks now. Okay, so now it's a bit more visible. So if we type in column 3, the program is colored in colored in the third column. But as you can see, it's posted in the bottom. The way we colored it, it's actually been rotated a bit. So here we'll have to change around. Instead of going through each element like that, we need to go, instead of going through each element through row by row and column, the way our board is situated, we actually need to go through it by each column and then each row. this should flip it around. And so essentially by changing the rate at which column and row changes, this will change the way it draws. So now it's changing it by each row first and in column. That's because the way we made the board in the original main program and the way we're drawing out here are a bit different. And so you have to kind of account for and make sure that you know what the format of your board or whatever you're drawing out looks like. Make sure that when you translate it to the window, that the formatting stays like it changes in order to match with the relevant window draw. Right. No. We changed the column, so this should. There we go. So let's see. Oh, that did not change, right? Because it is this. Oh wait, no. I'm being dumb. I didn't. Actually, uh, uh, oof. Gosh, being dumb. Yeah. So it needs to be so. This is them. Down. Great. Necessity is my in order to flip the board around needs to, when we draw, it needs to go from draw first. Okay. That works. What? Am I being done? I think I'm being done. Oh, it's because wrong columns. I am being done. Didn't actually. Okay. Oh, I wasn't even changing anything. Okay. Oh, whoops! I changed too fast. Moving down. Hooray. Just reversed. Right, and this can go. Okay, there we go. Now I can. Shoot. Finally work. Yay. I reversed it. Hooray. Okay. Hooray. I had a small brain moment, but yeah. So as you can see now, the board is working as it should. I messed up the X and Y without I was looking at it. But yeah, so as you can see now, it's now drawing in the correct positions, no matter what column row we pick. Now, so the reason, okay, so the reasoning it works is because first off, we have to go through each element in each row. The problem is the row, the specific, the one the for loop is using, the row and column, don't completely correspond with the actual place you're supposed to draw it on. Specifically, the column represents what column the element in the board is, but that's not actually, but column, despite being the vertical part, is not, it's actually its Y value, it's actually its X value, because the column you're in changes as you move left to right. If you move up and down in a column, you simply change your position within the column. You're not actually changing columns. And whereas with row, while rows represent each horizontal bar, rows change vertically. If you want to go to a different row, you have to move up and down. So that actually makes this the X value rather than not the Y. And this makes it the Y value whenever you're supposed to draw it and not the X value. Essentially, the number row you're on indicates what Y position you're at. And a column represents what X position you're at. Because when you change column to change rows, you don't change along a column. You have to change to each different column, and that you do that by changing your horizontal position. I accidentally reversed it, which is what the first time I did it. But yeah. And so now it's drawing it well. Every time we enter a number, the program will run through this code again. As long as no one has won yet, it will put the specific column. It'll take the column and put the specific piece in. It will then set the current board over the old board inside the panel class. And then it will tell the panel class to repaint itself every time. And so this way, it's constantly going to update until we reach the win condition, which in Connect 4 is connecting 4 pieces of the same color together. As for this output here, you can also translate that onto this window. instead of using draw ovals or fill ovals, you can simply tell the program to do g.draw string. And using this, we simply give the program some words and a specific X and Y coordinate to draw or write the word at. In order to actually do this, you will have to either copy and paste this check win code and check tie code into the panel. The panel knows when to actually draw it, or you can simply implement another method that tells like set board. That's similar to set board, but instead of setting the board, you set the win or game state of the program. And so it can then using that, you can tell panel when the game wins. Either approach will work. It's simply a matter of all that matters is how you get the input of the board, the operation, and how you get the operations of checking wins and the result over to panel. You could bring the whole input and operation to panel together, or you could just use methods to transport just the output to panel in order to get to draw the string of winning. And again, this right now is just really basic drawing. All it does is just draw the very base of the board. Whenever you create a program, especially if you're going to go through the effort of giving a window, you definitely want it to look way more present, official. Like for example, here, we're not using all the space. So one good method to do this would be either to shrink the size of the window from 800 to like say 600 by 500 so that it fits in here much more nicely. And another thing you could do is by giving a background color. An important thing to note is that the way Java handles like backgrounds is you can tell a program to specifically paint something in the background or foreground, so it'll appear behind or in front of objects. But if you don't tell the program, it'll automatically default to the latest object will paint on top of everything else. So the first circle we paint here, if we paint another circle on top of it, it would be covered. Whereas the later circles would be the last ones to be covered because they're the last ones drawn. So if you wanted to say give it a background, it would have to be the first thing drawn so that the circles go over it and you can actually see it. So for example, that is a lowercase g, but the name is uppercase. I could fill the whole board with a black background color. Right, everything else is white. No, it's not the color. Green. So now we by painting the background, what you did here is we told the program to set its color to green, and then we simply fill the rectangle that started from the very edge corner, and that started from 0, 0, and then filled a length and width of 800 by 800, which is the size of this window, in order to fully cover it with the background. The reason that the reason that the black one didn't work is that these spaces were all empty. Draw circle only draws a black, only draws like an outside line, which in this case happened, which I set to black. So the black and the black blended together. So all you saw was that red spot. So you have to make sure when drawing, obviously, that the colors match together and do well, but that's more of an art thing. Just as long as the colors aren't exactly the same when they're supposed to be different, and you're good. But yeah. So essentially, the main idea to take away from here is that if you want to draw out the actual program output, if you wanted to show up onto the screen, you have to create a frame to contain the draw window, and you have to create the draw window itself. And the draw window will contain a paint method, which is what you actually use to change the state or the content of this window. And an easy way to draw the things in here is by using multiple for loops, because a lot of times like lots of symbols and stuff are repeated. So you can use a for loop to kind of shorten the time on that. So that we don't have to draw each individual circle. This for loop, because we know for a fact it goes through every element in this list, we'll be able to draw each element here. They just have to make sure that the row, column, X, Y match together as well. So yeah, that's the basic paints. Later, there's also other things you can do with this screen as well. For example, right now, all we did right now is draw onto it, but there's also ways to interact with it. Specifically, what we do right now, all we've been doing is using user inputs from like key presses. But as I'm sure all of you know, another major way computers get input from users is the mouse click. If they click on a button or if they click on some part of the screen, the computer will be able to recognize it and do something about it. And so that, obviously that can only happen with something to click on, and which in this case specifically will be this window, this frame. If you don't create a frame window, you can't really listen to mouse input. There's no scanner for mouse input normally because there's nothing to click on here. The only thing is the terminal down here. So in other words, it's like different. Unlike scanner, which is just a simple object you can create, it goes in this that gets input from the terminal down here. In order to get mouse input, you have to first create a window to actually click in. And then secondly, you need to tell the program that this window is not just meant to be a visual marvel, but it's also meant to take in mouse inputs. And you would do that by implementing so essentially, the first part, the extends, identifies this object, this class, what it's supposed to be. This by expanding JPanel, the program knows this Connect4 panel has an identity of a JPanel. It's supposed to be a window. Implements are different. In this case, implements means use to add on to. Essentially, this means this panel, we add on the ability to listen for a mouse. And mouse listen is fairly simple. It will automatically create these 5 methods, and these methods are exactly the same. The only difference is when they actually happen. For example, mouse clicked, it will run this method after your mouse has been pressed down and up. So after you click and then after you release the mouse button, after both of these have occurred, it will then run. Mouse pressed is simply as soon as you touch it. So as soon as you push down, it will run. This is mouse release. So it will only run after you release the mouse. Mouse entered is when you enter something. More specifically, in this case, it's when you enter the window. So as soon as the mouse enters the window, it'll run this one. And if the mouse exits the window, it will run whatever's in here. You can also later, if you manage to, you can create like smaller windows inside larger ones. So that's what this main one's used for, whenever you exit or enter various other windows. The only one we really have to care about right now is mouse click, since this is the main one that deals with the actual clicking of the mouse. So the input here comes from right here. Every time you click the mouse, it will run this method, and the clicking of the mouse, it gets transformed into a mouse event by the computer. And this is essentially the user's mouse input. In order to use it, mouse event is an object, so that means it contains its own methods and its own information. And the most important of this information is the mouse's position. For example, in the X position of the mouse, and simply take the mouse event and get the mouse's X position. Specifically, you're not getting the mouse's position, you're getting wherever the mouse clicked, that it's X position here. You take the name of the container that's holding the mouse event, then you tell it to get the X value. And for Y, it's the same thing, but instead of get X, it's get Y. Mouse event also holds various other stuff, such as the click count, or this is a different way of getting the X and Y values, et cetera. But really the only things we care about, like 98% of the time, is the number of times you click and also the X and Y position. So now that we have the X, Y position of the mouse, we can then use it. For example, if you wanted to create a pseudo button, what you could do is you take the X and Y position. And if it's within a certain rectangle, like for example, if the mouse X is greater than the rectangle's X point, like at 10, for example, and X is less than the other side of the rectangle, which would be its starting point plus its width, say 10 again, and its Y position is saying it's within its, if Y is within this rectangle's first point and then its other point plus the height, where these are true, and that means the user is clicking inside of the button area, right? So then you could then tell the program to do something else, like if the user clicks this specific area, or in other words, like this button, then you run, for example, a different method. You can run, say, you might say this is the repaint button. This is where the user can manually tell the program to repaint. Or you could create your own method, like redraw or like reset. You could create a method called reset in this case of Connect 4. And this method could, for example, just reset the board. And so you would simply tell the program call reset, and reset might just set board to an empty board. So this is how you would get mouse inputs instead of just keyboard inputs. Remember, this only works with a window, since that's the only thing you really, since that gives you an area to actually click on things. Without a window, you can't. I mean, you can still implement mouse listener, but like there won't be any mouse events that will actually happen, and it will basically be useless. So essentially today, so the class is almost over. So we're going to go back over to what we mostly did today. Today we're going to review how the programs, the media parts, are the input, how you get user from the data, how you get data from the user, the operations where you transform that input and do various things with it to get what you want, and then output, where you then actually return whatever you want, or return like the image. And one way we can create a new fancier output is instead of just using text, instead of just printing out text into vast miles, into like fake images, you can actually create actual images through the use of a frame, which contains a window, and then a panel, which puts a draw panel inside a window and allows you to actually draw stuff onto it. Each frame and each panel you need to set its visibility to true, and you also need to set its size to something. And then the next important thing is paint, which actually draws onto the panel and draws stuff. In this case, we drew a bunch of ovals to represent the board itself, the Connect 4 board. And panel can also contain mouse, can also check for the mouse position, the mouse actions. So now this also allows us to get more than one type of input. We can get mouse input instead of just keyboard input from the user. And of course, the way to actually use this is you have to create their own separate class, or you have to create their own separate class. And then you have to create an object similar to how you create a scanner, for example, in it's mostly the same format. You create the name of the container, the class it holds, and tell it to hold a new class. And then when it runs this, it's going to, so essentially this creates a cPanel, an object with the name cPanel that holds a Connect frame. This Connect frame passes in a board as input, and it will take this board, and its specific operation is by passing it into the panel that is connected to this frame. It's going to add this panel. It's going to create a new version, because remember, this constructor is only run when it's first created. So when it's first created, you also want to create the panel at the same time. And you want to add the panel to the frame itself. If you don't add it, then it's just going to create a separate panel that's like not related to anything. So you need to add the panel to the frame. And then the panel actually does the drawing and stuff. All right, that's it for today's class. If you have any questions, you can stay behind and ask, but otherwise, that's it for today.
Bye.
Bye.